This tiny teaches about the pGLO Plasmid transformation lab. Transformation is taking up DNA from the environment. We used E. coli in this exercise, and E. coli is not naturally competent. We grew E. coli in the presence of calcium chloride and used extreme temperature change, or what's known as heat shock, to make E. coli take up the pGLO plasmid from the environment. The pGLO plasmid was made as a way to demonstrate basic gene regulation concepts. On the pGLO plasmid, you'll find ORI. ORI is not a gene. It stands for origin of replication. It's where the bacterium would start replicating this plasmid. ARA-C is a gene. It is transcribed and translated all the time, producing the ARA-C repressor protein. ARA-C, the gene, and its ARA-C protein control transcription and translation of GFP. BLA, the gene, is transcribed and translated all the time, producing beta-lactamase. Beta-lactamase breaks apart antibiotics like penicillin and ampicillin. GFP, the gene, if transcribed and translated, produces green fluorescent protein. This is what makes jellyfish glow. GFP is not transcribed and translated all the time, like the ARA-C gene is and the BLA gene is. Instead, GFP transcription is controlled by the ARA-C gene and the ARA-C repressor protein. Now let's take a look at the regulation of GFP in a little more detail. Here's the GFP gene, and you can see the transcription of that gene is being blocked by the ARA-C repressor protein. RNA polymerase can't come in and transcribe the GFP gene. If we add Arabinose to the media, we inactivate the ARA-C repressor protein, so now RNA polymerase can come in and transcribe the GFP gene. Let's take a look at some of the plates that we have in the pGLO transformation lab. This is control E. coli, meaning this E. coli did not take up the pGLO plasmid, growing on just Luria agar. You can see there's nice growth on this plate because Luria is an excellent media for E. coli. But this bacteria does not glow like a jellyfish because it did not get the pGLO plasmid. It does not have the GFP gene. It cannot make green fluorescent protein. Our next plate is control E. coli. So this is E. coli that did not pick up pGLO plasmid from the environment, growing on Luria plus ampicillin agar. You can see there's no growth on the plate because E. coli is sensitive to the antibiotic ampicillin. Here's pGLO E. coli, meaning this E. coli did take up the pGLO plasmid from its environment, growing on Luria plus ampicillin agar. Here you can see there is growth on the plate. The bacteria got the pGLO plasmid. They have the BLA gene. The BLA gene is being transcribed and translated all the time, producing beta-lactamase. Beta-lactamase is breaking apart the ampicillin in the agar. These bacteria do not glow like a jellyfish because the ARA-C repressor protein is blocking transcription and translation of GFP. Here's pGLO E. coli. So this E. coli took up the pGLO plasmid from its environment, growing on Luria plus ampicillin plus Arabinose. There is growth on this plate, again, because the bacteria picked up the pGLO plasmid. They have the BLA gene. They're producing beta-lactamase that's breaking apart the ampicillin in the agar. These bacteria also are finally glowing like a jellyfish. That's because the Arabinose in the media inactivated the ARA-C repressor protein, so GFP could be transcribed and translated, producing green fluorescent protein.